Hello students, we are going to start chapter 4 carbon and its compound. In the previous chapter we have studied the ionic bond structures. In this chapter we are going to study the covalent bond structures. How the covalent bonds are formed and why the atoms undergo covalent bond. Before starting the chapter we shall discuss that many of the things which we use, they are made up of carbon. Whether it is a toothpaste or a toothbrush or food or the clothes which you wear or the medicines which you eat, all made up of carbon. The question arises, why this carbon can make such a huge number of compounds? Why cannot make? So you are going to get the answer of this question in this chapter. Bonding in carbon, the covalent bond. Carbon forms the covalent bond. How it forms the covalent bond we are going to study in this chapter. In the previous chapter, we have studied the properties of ionic bond. That is, ionic compounds have melting point and they are good conductors of electricity in the solution or in the molten state. Now let us go through the properties of the carbon compound. If ionic bonds have high melting point and boiling point, then carbon compounds will have low melting point and boiling point. If ionic compounds are good conductors of electricity, then carbon compounds, that is covalent compounds, are poor conductors. The carbon compounds are poor conductors of the electricity. Why the carbon is poor conductor of electricity? We know that electricity is the flow of charge. Ionic compounds are good conductors of electricity because the electrons flow through them. They have ions. So there is a charge. So the electricity can pass through them. It means that the carbon compounds, they are poor conductor of electricity because they don't have. If ions are not there, no conduction takes place and hence poor conductor of electricity. And they have low melting point and boiling point. Why they have low melting point and boiling point? Because the carbon compounds are in solid state, but the force of attraction between the atoms are not so strong enough. So due to this reason, they have low melting point and boiling point. Suppose carbon. Carbon's atomic number is 6. Electronic configuration is 2,4. So how many electrons it requires to become stable? It requires 4 more electrons to become stable. Suppose carbon takes 4 electrons given by some atom. It gains C4. Carbon has taken 4 electrons gained by some atom and it gains a charge of C4 minus. So the protons, the number of protons present in this is 6. The number of protons which are present in this carbon is 6. Were also 6. But in this, protons will be 6 but the electrons becomes 10. So a carbon atom with the nucleus of 6 protons has to hold 10 electrons. It is tough with the 6 protons to hold 10 electrons. From where do they can get the energy? So this case is not possible. Similarly, carbon, if it gives 4 electron, it becomes 4 plus 4e minus. The protons in the carbon is 6 of this carbon and electron is also 6. But in this carbon, the proton is 6 but electrons changes to 2. Means a nucleus with the 6 proton is holding only 2 electrons. Then where the remaining energy will go? It will be wasted. So carbon cannot go for this also. So it satisfies this property by sharing the electron. So carbon forms covalent compounds. Covalent compounds are formed by Sharing of electrons. How the sharing of electrons takes place? Let us start. Hydrogen. Simplest example is in the form of H2. Okay. First step is write hydrogen atoms. How many hydrogen atoms are here? Two different. Atomic number of hydrogen is 1. Atomic number of this hydrogen is also 1. Electronic configuration is 1. Its electronic configuration is also 1. Number of valence electrons. Valence electrons are the electrons which are present in the outermost shell, is 1. So you have to represent the either with the cross or with the dot. So I am representing this valence electron of this atom with the cross and this with the dot. Now how the sharing takes place, you have to show, you have to draw a circle. This hydrogen atom has become stable. Similarly, for this hydrogen atom, this circle indicates that this hydrogen is stable. This circle indicates that this hydrogen is stable. So this is electron dot structure. Now you have to write electron bond structure. Sharing has been takes place. 2 electrons are going for the sharing. So you have to write the bond in present of that. In this way the sharing takes place, and in this way the covalent compounds formation takes place. One more example. Chlorine. 2 chlorine atoms. First you have to write chlorine. The next step is to write the atomic number of chlorine. The next step is to write the electronic configuration. 287, 87. So how many valence electron? There are 7 valence electron. Okay, 7 valence electron. So chlorine, 7 valence electrons. I am showing the electrons of this chlorine atom with the cross. Whenever you draw, put the electrons, it should be in 4 different directions. It should also be in different directions. Now show the sharing by formation of the circle. Show the sharing of this chlorine also. This chlorine, the circle this indicates that this chlorine is stable, and this circle indicates that this chlorine has been stable. The electron which is shared is, you have to show the bond structure. So this is the covalent bond structure of chlorine atom. In the same way, we can draw the covalent bond structures of different atoms. See, I have drawn in my notebook hydrogen, the bond structure of chlorine, and the dot structure of hydrogen. This is chlorine, electron dot structure, and this is the bond structure. Similarly, I have done 10 examples. More I'll draw it here, and then remaining examples I'll be sending you the PDF. I'll take with the oxygen O2. First write atoms, first step. Next, atomic number. Atomic number of oxygen is 6 and atomic number of oxygen is 6. Electronic configuration is atomic number is 8. Electronic configuration is 2, 6. How many valence electrons? 6 valence electron. More, how many valence electrons it requires to become stable? More, it requires 2. So what is this oxygen does? It shares 2 electrons with the other oxygen atom. And this oxygen will also share 2 electrons. This is the circle that this oxygen is stable. This circle indicates this oxygen is stable. So this is the electron dot structure of oxygen, and this is the electron bond structure of oxygen. So double bond in between them. Similarly, one more example of ammonia, NH3. So nitrogen and hydrogen, 2 different atoms. Nitrogen's atomic number is 7, hydrogen is 1. Electronic configuration of nitrogen is 2, 5 and hydrogen is 1. So 5 electrons. It requires more 3 electrons to become stable. So it shares 3 electrons with 3 hydrogen atoms. So this is the circle which shows that nitrogen is stable. This is the circle which shows hydrogen is stable. This is the circle which shows second hydrogen is stable, and this is the circle which shows third hydrogen is stable. So the bond structure is of NH3 is this. So in this way you have to draw the electron dot structure and bond structure. Okay, I have discussed 4 examples on the sheet, and remaining examples I have done in the notebook. This is oxygen, this is nitrogen, this is ammonia, this is H2O. So first you have to go with the atomic number and electronic configuration electron and write the valence electron and draw it and show it in the form of circle. In this way I have done 10 examples in the PDF in my notebook. I'll be sending the PDF of this. Next, allotropes of carbons. What are allotropes? The first question is, what are allotropes? Compounds in which have different physical which have different physical properties but same chemical properties. The compounds which are formed with the same element which shows different physical properties but they are having same chemical properties are called as allotropes. The element of the carbon occurs in different forms in the nature with different physical properties. Allotropes of carbon are diamond and graphite. You can get a 3 marks question to differentiate between the substance and why graphite is the soft substance. Why diamond does not conduct electricity and why graphite conducts electricity, though both of them are made with the carbon. You will get to know the answer of these questions in these points. In diamond, each carbon atoms are bonded to 4 other carbon atoms forming a 3-dimensional structure. Each, that is one single carbon atom, bonds up with the 4 different carbon atoms, giving rise to the 3-dimensional structure. But in graphite, one carbon is bonded to 3 other carbon atoms, giving rise to an hexagonal array structure. So this is the first point. In the first point, you are going to write that each carbon atom is bonded to 4 other carbon atoms, and in graphite, each carbon other carbon atoms. Okay, so this is the first point, that in diamond each carbon atom are bonded to the 4 other carbon atoms forming a rigid 3-dimensional structure, whereas in graphite each carbon atom is bonded to 3 other carbon atoms in the same plane, giving rise to the hexagonal array structure. All the bonds in the diamond are single, but in graphite one bond among the 4 bonds is a double bond. Okay, one bond is structure and it is a hexagonal array structure. That is, this hexagonal array structure are placed one above the other in the form of layers. Hexagonal array structure is nothing but honeycomb structure. Due to these 2 different structure in diamond and graphite, they have different physical properties even though their chemical properties are due to bonds. Each carbon atom is bonded to 4 atoms, each carbon atom is bonded to 3 other carbon atoms, and one bond between them is double bond. So they have different physical properties but same chemical properties. Due to these structure, diamond is the hardest substance known while the graphite is smooth and slippery. Fluorescence of another class of the carbon allotropes. The first one to identify was C with 60 carbons. Okay, fluorescence is another allotrope of carbon in which 60 carbons are attached, which are arranged in the shape of football ring. Okay, today I am going to end my topic till here. Thank you.